All right, just doing a little bit more test prep. I think I'm going to keep working with this same problem because it's been pretty useful for me. I'm going to take a look now. I want to put these in more real terms. Okay, so why is that doing that? Oh, I know why. Okay, yeah. Okay, so I want to look at these values here, and I want to see, well, actually in the reactants, I want to see what kind of a volume is 3 moles of carbon dioxide. Okay, how much space is that going to fill? Okay, I'm not going to teach anything from scratch. I'm just going to work through the problem here, and if you follow along, that's great. If not, or if you can tell me a better way to do it, that's even better. So I think this is the one we just finished. Well, we don't need that anymore. In fact, we don't need most of this anymore, other than just the 3. Whoops. Tell you what. Let's just declutterify everything. Okay, so blah, 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 new layer. Okay, and I'm just going to say 3CO2. All right. Well, there are a few ways we could go about this, I suppose, but let's make a couple of assumptions. Let's assume, as is fair to do, that we're working at STP, which is standard temperature and pressure, and that's going to be 0 degrees Celsius, okay? And that's going to be 1.0 atm. All right, now to get this done, I'm going to make use of something called the ideal gas law. I'm really not sure how this is going to turn out. I'm just trying it out for size, see how it all comes together. So here's what I know. All right, the equation is PV equals NRT. Okay, assuming these conditions are true. Okay, so there are a few things I've said already. I've said that the pressure is 1.0 atm. Okay. Oh, yes. Okay, this could be interesting. All right. So times the volume, which is what I don't know. So I probably didn't even need to put a parenthesis there. I just put a V for volume. Okay. And I'm going to say how many moles is equal to how many moles of CO2. Well, we know that from the formula from the last video. It's going to be 3 moles of CO2, right? And then R. Okay, now see, I thought I'd be ready for this, and my notes are so kludged up that please pause. So hang on a second. And I'm back. Hardly seems like I was gone at all, right? Okay, so yeah, I was looking for the value of R, and it's a ratio that I'm not going to go into details because I would probably screw it up anyway. But for our purposes, it's just going to be a number, and there are 2 ways you can present it, and that's what stalled me. I was trying to decide which one to use. In this case, because I wanted to find the volume that this CO2 would occupy, right? That's what I'm solving for. I think I'm going to work with liters for my unit of volume. So that's going to put my value for R at 0.08206. It's an 8206. Okay, and then from that, that's going to be, oh, let's make sure we get the units in there, because that kind of helps to, at least in my mind, to figure out how I'm supposed to solve this and where I should end up in terms of units. Okay, so R is in liter ATMs. See, that's handy, right? Over temperature per mole, or Kelvin moles, right? Then, right? We'll find out. All right, because we're looking for volume. That's R. The temperature we said was standard temperature and pressure, right? So you might be tempted to put a 0 in here, but that'd be really bad, because then you'd have one times something equals 0, and you'd say the volume equals 0, and that's just not going to work. That's why for PV equals nRT, you always want to use, what was that? Okay, you come back, don't stall, no. What just happened to my mouse? Okay, I don't know what just happened there, but I'm back. Whoa, scribbles. Okay, so as I was saying, I guess the computer didn't like my attitude. For temperature, if I put 0 here, I'm going to end up with 1 times something equals 0, right? And the only thing I could put in there to make it 0 for the volume would be 0, and 0 volume makes no sense, okay? Even that dot, well, that's two-dimensional, so yeah, anyway, we won't go there. So let's back up a little bit. How can I make that not be 0? Well, I kind of give a clue here in the units, and that's why knowing these units for the values of R will help you solve it better. Because now I can say, well, I want it to be in Kelvin, right? Well, if I have 0 degrees Celsius, I can add 273.15, and when I get done with that, it's Kelvin. That's really easy, right? So I say 273 point. This is not keeping. I'm telling you, I can get that checked. Okay, 273.15. 0.15 what? Kelvin. That's not kilos, it's Kelvin. It's a capital K, and there's no degree sign there. Okay. All right. Now we can start solving things. But before we do all that, let's do a little bit of happy unit cancellation. So these cancel out, right? Okay. ATMs. Well, if I divide both sides of the equation by ATM, I get that and that, right? Kilograms per mole. Okay, well, I can keep that in for now. Okay, let's do some arithmetic, right? Multiply out the numbers, and here's what I get. So, deleting, and I start out, okay, this pretty much all goes away, right? So I say V is equal to 3 times 0.08. Oh, sheesh. Lag is confusing. 0.08. 206. I'm going to double check my number there because I really don't want to screw that. That's right. Okay. Yeah, I'm going to put that in there. And then I know that the temperature is 273. 273.15 because, you know, boy, I want to get this right, huh? Well, it really won't matter once we get done with sig figs, but there we go. So I've got those three things in. I'm multiplying them all, right, according to the equations. So here we go. Times, and that gives me an answer of volume equals 67, and looking at sig figs, well, you know, I only gave you 1.0 here. No, fudge, because I like more numbers. Okay, so 67.2, and what are the units? Well, let's see. I've got moles here, right? And I've got liters here, so I could say and I might be wrong. Yeah. Because this I should have said 3 moles. Okay, that's where I screwed up. Boy, watch those units, how they'll kill you. Okay, more happy cancellation here. Liters is what I should have ended up with, right? So 3 moles of carbon dioxide is going to come out to 67.2 liters of CO2 in the reaction from the previous couple of videos. And that's it. That's getting the volume from just the molecular mass. Did I say that right? No, the number of moles. I'm out of here.